Swayam Prabha. Digital India. Educated India.
Hello, this is the fourth lecture on axial flow compressor. The contents of the lectures are rotating stall and surge in axial flow compressors. Then I'll discuss on compressor performance. I'll discuss here in brief regarding rotating stall and surge that occurs in axial flow compressor. Regarding rotating stall, I would like to say that it is a phenomena of axial compressor flow that has been subject of many detailed experimental and theoretical investigations. In brief, when the rotor of a compressor reaches the stall point, the blades, instead of stalling together as might be expected, they stall in separate patches, often called stall cells. Thus, stall cells are the patches of separated flow that occur within the annulus. Furthermore, these stall cells propagates around the annulus at almost half of rotational speed of the impeller. With respect to the stall cell propagations, I like to add that at a high angle of attack, it might be expected that all blade would stall uniformly as seen in the cascade flow analysis. I'll explain now the propagation and formation of stall cells through the schematic in the next page. Through a schematic here, I have tried to explain the mechanism of formation of stall cells and its propagation. Here I have indicated the flow past a cascade, a series of blades, where it has been observed that after a certain angle of attack, all blades will stall uniformly, developing separated flow on the suction surface. However, this uniform stalling has not been observed in rotating blade in compressors, where a group of blades stall, causing a partial flow restrictions. Now this patch is called the stall cells. And because of this partial blockage of flow, the incidence to the neighboring blades would change, causing the stall cells to propagate. This I have explained here in brief, as have written like this. In general, the flow instability will cause a small group of blades to stall before others in a blade row. Thus, the separation from the suction surface of these blades in a group results in a severe flow restrictions in the blade passage. Furthermore, this group of blades is no longer capable of supporting the pressure rise. Thus, partially stagnated region or regions will be formed around the compressor annulus, and these patches are called stall cells. What is the effect of these stall cells? That because of these stall cells, because of this partially blocked region, the incoming air is deflected, and thereby the angle of attack would increase on blade immediately above the stalled blades, while the angle of attack on blade below the stalled region would decrease. Thus, the blades above the patch will be susceptible to stall, and the blades at the bottom of the patch would unstall. The process is continuous, and thereby the stall cells propagates upward for the blade orientation in the annulus. It has been observed that the speed of propagation of stall cells is about the half of the blade speed. Furthermore, there is a strong practical reasons for the wide interest in rotating stall. Stall cells or patch traveling around the blade row load and unload each blade at some frequency related to the speed and number of cells in the annulus. If the frequency be close to the natural frequency of the blade, then the rotor will be pushed to severe vibration. Several cases of blade failure due to resonance induced by rotating stall have been reported. Let me discuss about the surge in brief. The compressor surge is a system instability which results in large fluctuation in net flow rate through the compressor and in torque requirements. It is possible to distinguish between the surge and rotating stall by the flow unsteadiness or otherwise by the total mass flow rate through the compressors. It should be noted that the characteristics of stall propagation is that the flow through the annulus summed over the whole area is almost steady with time. Surge, on the other hand, involves an axial oscillation of total mass flow, a condition highly detrimental to efficient operation of compressor, leading to the failure of engine. The surge is very dangerous, which may lead to the failure of engine because of flow oscillations. It should be noted that the point a compressor enters to stall or surge still cannot be predicted reliably even with the most advanced computational method. Furthermore, it has been observed that the surge is triggered by the occurrence of deep rotating stall. So there is a relation between the stall and the surge. So deep rotating stall often triggers surge. Furthermore, the inlet flow distortion because of partial blockage of annulus leads to the flow instability, inducing an early surge. Thus, the surge is triggered by deep rotating stall and also because of inlet flow distortions. The performance BAF or the performance characteristics of multi-stage axial compressor of a turbofan engine has been presented here graphically, where the pressure ratio across the machine is plotted as a function of mass flow rate m dot root over T01 by P01 for stable operating speed omega by root over T01, superimposing the contours of compressor isentropic efficiency. Furthermore, the operating line, which is indicated by the dotted line, is presented here with surge line, which has been indicated by red. So look, this is the characteristics as speed increases. Each of the constant speed curves on the compressor characteristics terminate at the instability line, often referred to as surge line, which has been indicated by red. Beyond this point, the operations is unstable. Suppose if we are in this region, the operation is not stable. At a high speed and low pressure ratio, that means if we are in this region, the constant speed curves becomes vertical. In this region of characteristics, no further increase of mass flow rate is possible since the Mach number across a section of machine has reached to unity. Thus, the flow has choked. A compressor can operate anywhere below and right of the surge line. Suppose in this region the compressor can operate. However, we usually constrain to a single operating line as expressed by the dotted line here. I like to state here that the design operating line is usually specified so that it passes as close as possible to the point of peak compressor efficiency. Thus, the term surge margin is often used to describe the relative position of the operating line and the surge line. The surge margin is defined here as Sm is equal to PRS minus PRO divided by PRO, where PRO is the pressure ratio at the point on the operating line at a certain speed, while PRS is the corresponding pressure ratio on the surge line at the same speed. With this definition, a surge margin of 20% would be typically used for the compressor in a turbojet engine. Thank you for listening.